Hey, everybody, this is Larry. This is day 28th. Oh, and is that nope, that's tomorrow. 28th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Is my computer lagging? I don't know. Wish you first to AC on the, I don't know which way, I always forget. But if you see it, click on it to get 10 coins. And today's prompt is sort away by parity. Given an integer array nums, move all the even integers at the beginning of the array followed by all the odd integers. Okay, so yeah, I mean, this is an easy problem, and I'm not just saying that to make you feel bad. It is labeled easy in either case. There are a couple of ways you can do it, right? I mean, you can just use a regular sorting by key, and of course, that's going to give you n log n time. You can also just do like a counting sort, or I guess counting sort is not quite the same, right one. But like you could do one iteration of the radix sort or something like that, like a bucket sort kind of, and that'll probably be fine. Don't If you're not careful, you're not going to do it in place. I think you could probably do it in place if you want to kind of challenge yourself a little bit. I'm just going down. Is there any follow up, right? Yeah, I mean, I think if you find this easy, definitely see if you can do it in place. And I think that'll be like a stretch goal. And the idea there is just, yeah, what do we need? We even in the beginning, yeah, just kind of go almost like a two pointers thing, right? Um, yeah. I think you can do two pointers. Let me think about this. I am intentionally making this a little bit harder for myself today, so we'll see how that goes. Because yeah, otherwise you could probably do it in one line, two lines, three lines. Challenge yourself. But otherwise, yeah. So the precondition would be that everything to the left of the index is of some index is going to be all even numbers, right? So yeah, so I think that should be fine, right? So you basically just start with, n is equal to length of nums, right? Length of umps, and then now for I in range of n, and then maybe what's it called? Beginning is even index is equal to 0, right? So if nums of I mod 2 is equal to 0, then you swap it with the even index, and that should be it, right? Yeah, so then nums of I, nums of even index is equal to nums of even index, nums of I. Ooh. And I think this idea, hopefully I'm not wrong, is very similar to what's it called? Is it the Dutch flag? Is that? I never learned that term, to be honest, when I was young. I mean, maybe it's a thing, but yeah, the Dutch flag, the Dutch national flag algorithm, where you sort zeros, ones, and twos, or like three things really, three colors, if you will. And here you're only doing two of them, right? So I think the idea is basically off that. And yeah, and that's pretty much it. I guess we just return nums afterwards. Let me run it real quick. Looks okay, right? You can of course add more things. They don't have to be unique, right? So, but yeah, I think it's pretty simple until I get it wrong. That'll be funny. Yeah, but the idea here is actually kind of. I mean, I think this is kind of cool, but it definitely is sometimes kind of take a little bit of time to wrap your head around for sure. Yeah, so what's the complexity here? This is linear time and all one extra space. I know that's not really requested, and and I always kind of make it a point or make it a deal, a big deal to point out extra n space, because in general, like if you're going to call a function, that function should be idempotent, or at the very least, like it shouldn't change the input, right? So like very often, right? Like it's like you have a function that's like, we return the sum of the arrays, but then suddenly your memory changes for all the arrays and then jump order. Well, like that's like, as an API user, you're like, hey guys, why are you doing this? Why are you like jumping my way? I just wanted to know the sum, you know. So that stuff like that. I mean, obviously that's a very you know created example, but stuff like that like I always try to make it a point that it's O of n actually. Even if you do it quote unquote in place, it actually is O of n space, because in reality, what you want to do is just reallocate the memory, right? But of course, sorting is one of the few, or maybe there are many other applications, but sorting is one of the obvious applications where now when you call it sort, maybe it's okay to actually sort the array in the memory that they give you instead of reallocating it and make it functional instead in terms of functional language kind of functional. Right, but so yeah, so linear time, O of 1 extra space, constant extra. That's all I have for today. What did I do in the past? Okay, in the past I did n log n laziness. Even more some craziness. What am I doing here? What are you doing here, Larry? That was 4 years ago. Have I been doing this for 4 years? Huh. And it's even in Python too. Huh. Huh. And yeah, and that's the this is the n log n again. And now just mod 2 by evenness. And here oh, I guess I just did the Dewey flag or the Dutch flag algorithm here. Oh, that's cute actually. So basically it just moves to the pointer in which these two invariants and then swap them. I guess this is also linear. For sure, but you don't, and apparently you don't even need to be that complicated. You just kind of, because the idea behind this one versus the other one is that the idea, and both of them have the idea around invariants and keeping loop invariants that are, that are true at the end of the loop or at the end of every iteration of the loop. Sorry, and for this one, the loop invariant is that left of the left pointer is going to be good and right of the right pointer is good. And here we just only care about the left pointer basically, in the same idea. That's kind of cool. But yeah, that's all I have for this one. I know it is a long-ish video for this kind of problem, but let me know what you think. Stay good, stay healthy to commend the health. I'll see y'all later and take care. Bye bye.